Hey Savvy people, it's Savvy Nick here, and today I plan on continuing the Python tutorial and learning about Python here on the python.org website. In the last stream, we learned all sorts of stuff about strings and some manipulation here for input and output. That was section, chapter 7.1. And we went through, output formatting. What else did we do? Formatted literal strings, used the format string method, and we read and wrote into a file. That was kind of exciting. Good to see you, Snaith. All right, so what else? We finally got down to serializing objects, so that's with JSON, and I got a little bit stuck on this here, so I did play around with that some more, and I was able to get something going and reading it back in and trying to serialize it. So what I was trying to do here, I guess, was write to a file, serialize the object, and then write it out to the file. So you can do that. I figured out what the difference between dump and dumps was. So dump allows you to serialize an object into a file. So you can specify what object you want, and I have this list object, and I can serialize it to F, which is the file I have open. And then afterwards, you can go ahead and read that file back in. And as you can see here, I read the file, saved it into Y. So that's a string. Print out that string, and then I go ahead and try serializing that string object again. But what I really need to do here is change this string into a list again. So I haven't really got that finished yet. Hey Matsu, nice to see you back. So I managed to go ahead and go through this a little bit. I understand it now, but I did not get it working the way I wanted to. But today we're going to go ahead and just move on to the errors and exceptions section of the Python tutorial on python.org. So that's section 8 here. It's called errors and exceptions. And we'll go through this together today and see where we get to. There's about 7 sections in this chapter. And if you are with me today, please hit that like button. It really does help me out. What I'll do here is I'm going to go ahead and slowly start on this section. So let's read about this now. So normally errors and exceptions are great because you don't want just the program to crash while a user is using it. This is a great way to handle those exceptions created by the program. So if there's something seriously wrong, you miss something, you access, let's say, memory in the wrong location in C and C++, this is a great way to handle those problems that come about, and that way you can gracefully either exit out of the program and tell the user, hey, there's something wrong, or just even continue. What I'll do is, let's read here. Until now, error messages haven't been more than mentioned, but if you have tried examples, you've probably seen some. There are at least 2 distinguishable kinds of errors: syntax errors and exceptions. So something wrong with the way you coded, or something brought up by the program which it can't handle is all that means. Hopefully everyone can hear me just fine. Let me know in the chat. So syntax errors, also known as parsing errors, are perhaps the most common kind of complaint that you'll get while learning Python. So here we're given an example. While true, print hello world. File standard input. Line 1, while true, print hello world, invalid syntax. The parser repeats the offending line and displays the little arrow pointing at the earliest point in the line where the error was detected. The error is caused by the token preceding the arrow. In the example, the error detected at the function print since a semicolon is missing before it. Gotcha. All right, so let's see. We can reproduce this. I'm going to go ahead and copy this into a program. I should create a new file here, honestly. There we go. We'll save that as I believe we're on lesson 10. Oh, not bad. There we go. Yeah, we're bringing in those likes. All right, so paste. Also, if you're new and stopping by to watch this tutorial today as I run through the python.org documentation, go ahead and subscribe to the channel for more programming videos as well as Linux tutorials. All right, so I'm just going to go ahead and run this, and it says invalid syntax, just like they showed us. We get this little caret here, but the caret actually showed up in another spot. It didn't show up quite here at the T. It showed up at the P. Interesting. Let me see if I do this, what happens. All right, okay. And then that's because I think we're just missing. What are we missing? While true print. Yeah, while true print. Does that work? And sure it does. We fixed it. We just needed a colon here. And what the program was telling us was, let's see if we make this wrong again. It says there's something wrong right before the P in print. Hey there, Pre. Nice to see ya. All right, let's continue on here. So something more interesting here is exceptions. Even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. So their example here is dividing by 0. That's always a problem. You can't divide by 0 because technically, I guess going back to math here, if I remember right, dividing by 0 leads to an infinite number. So you can't do that. Computers don't understand infinite numbers. So it says right here, it actually creates a exception and it tells you you're trying to divide by 0. Another one here. They're doing 4 plus spam times 3. Well, I don't think they define spam. So as it says here, name error, they did not define spam as a variable. Another thing that they're doing here, they're trying to combine a string with a number. So this isn't a math operation. This is almost like a concatenation, but you can't do that because it says it can't convert the integer object to a string implicitly. It can't just guess that you want to change this into a string and concatenate the two. Instead, it's just going to throw up an error. Hopefully that all makes sense to everyone. All right. So we kind of went through all of those. I don't think we need to actually write them out. So we have a list of built-in exceptions here of Python. Let's see. Does this give us any kind of good information? So this just gives you the types of exceptions that can occur and what their names are and what they mean. This is a good reference if you ever run into some kind of a problem, either in the compilation of the program. So you'll see it down here when it's trying to compile everything. You can go back and reference these names in order to figure out what exactly is happening if it's not making sense to you. That's a good little thing to keep in mind, this built-in exceptions page. Let's see. So what happens if we do get an exception? Well, this just means it gets spit out and your program's either not going to run or it's going to fail mid-run. How do you handle those exceptions? That's 8.3 here, and I think I'm most interested in this. So let's go ahead and try their program here. It is possible to write programs that handle selected exceptions. Look at the following example, which asks the user for an input until a valid integer has been entered, but allows the user to interrupt the program using Control-C or whatever the operating system supports. Note that a user-generated interruption is signaled by raising the keyboard interrupt exception. All right, so while true, try. So it says while true, so infinitely looping here. Let me set this over. It's trying to ask you for an input that it's casting as an integer, saving into X, and it's going to go ahead and break out of that. Otherwise, if you don't give it an integer, some kind of an exception arises. It says accept a value error, and it's going to print out something to you. So let's give this a shot. As I suspect it works here. Let's confirm that. All right, we don't need this first thing. And I'm going to put in Python up top so it knows how to interpret this. And here at the bottom we see, please enter a number. So first off, let's go ahead and enter a number. Everything went fine, no problems. Let's give it another shot. This time, let's enter a character, like A. Oh, look at that. Oops, that was no valid number. That's an interesting way of saying it. That wasn't a valid number. Try again. So if we keep entering in, different characters here, you'll see that it keeps failing until we enter a proper integer and then it exits out of the program. Well, why is this the case? Because we have this try except block here, and if an exception is created, we're going to go ahead and drop into here. Otherwise, we're going to keep trying this first few lines where we grab a number from the user. All right, so what if we do, forget the break, remove that. We should always be able to enter in information now. So I think we can, as long as you want, and if you hit a, character or something, or a symbol maybe, you'll get this oops clause here that tells you you had an exception, you need to try again. Very good. So this is the very basics of trying to handle an exception here. If you didn't have the try here, and let's see what happens if you don't have a try, an exception block. If I entered a in, oh, well, true. How did it handle that exception? That's interesting. I'm going to remove this. We'll try again. So we're entering in numbers. Well, something's not right because it's still picking up on what we had last. So let me exit out of here, retry once more, because I'm sure it wasn't compiling what I was telling it to compile. All right, and then if I put an A here, here we go. This time we can clearly see that we had an invalid literal for something we're trying to cast as an integer, and it even tells us what it was. So it did handle the exception, but it handled it by exiting out of the program, and it's telling you that, and it says that it had a value error. So this is what happens if you don't have the try except block. Let's it's not very helpful to a user just to exit out of the program and tell them what, without telling them what happened, especially if you can go ahead and recover from an exception, which in this case we could, because all we did was we just went back and asked the user, hey, please enter a number instead. Please enter a number instead if they keep giving the wrong thing, which you could definitely count on happening. User's not always going to get what you want from them and understand what they need to put into your program. So they'll try all sorts of stuff, and they can make your program fail if you don't handle those exceptions. Glad to see everyone on today. Hope everyone's doing well. I see a few familiar faces here. If you're just joining us, make sure to smash that like button for me. It really does help me out. Let's go ahead and continue on with these exceptions here. All right. So our try statement works as follows. First, the try clause and statements between the try and except keywords is executed, so this is always executed first. If no exception occurs, the except clause is skipped, so it skips right over this. And then if an exception occurs during the execution of the try clause, here, if an exception happens, then if its typed matches the exception named after the except keyword, so it has to match this value error. And as we saw in our program here, it did throw up a value error, therefore it could go in this exception. If it was something else you were looking for, it would not go into the section. So if it matches the except keyword, and it did, then the except clause is executed. This is executed. And then the execution continues after the try statement. So it goes through here, you raise an exception, as long as it's a value error, it goes through here, and then tries again. If an exception occurs which does not match the exception value here, then it is passed on to the outer try statements. If no handler is found, it is an unhandled exception and execution stops. So basically what happens is you get this type of an error here and it exits out of your program, so long as there's not another try except block outside of this one. So if you have them embedded in each other, then of course it's going to go through the hierarchy and say, hey, I'm going to try the last known exception and keep going until, it just completely gets out of the scope of everything and then fails and exits out the program. All right, got a good understanding of that. We'll continue on. A try statement may have more than one except clause. Oh, interesting. To specify handlers for different exceptions. So we're just saying it can have multiple exceptions. A class in an except clause is compatible with the exception if it is the same class or a base class thereof, but not the other way around. An exception clause listing a derived class is not compatible with the base class. For example, the following code will print B, C, D in that order. All right, class B, exception pass. Class C, B. All right, for CLS in B, C, D, try raise CLS. All right. Note that if the except clause was reversed with except B first, it would be printed BBB in the first matching except clause is triggered. Interesting. I don't know why they gave us this example. They didn't really explain anything here. This is kind of thrown in the middle of everything. I don't necessarily like this. This is too much too soon. We won't go over that. We'll just continue on to some stuff that we already understand. All right. The last clause may omit the exception name or names to serve as a wildcard. Use this with an extreme caution since it is easy to mask a real programming error in this way. Okay. It can also be used to print out an error message and then re-raise the exception. So what are they doing? They're importing something. They're trying to open up a file called myfile.txt. They save they read a line in from my file into a string called s, and then try interpreting or casting that line as a number, an integer, and they strip out, I assume strip probably means to get rid of any spaces, but either way, they're trying to take whatever in from the file and change it into an integer. Hey Dinesh, Dayush? Not sure how to pronounce your name, but nice to see you. Glad you could join us today. So, you can see that if we get an OS error, so I don't necessarily know what an OS error is, but we can always go over here and maybe we can find it. Does it have the definition of OS error? Okay, exception OS error. This exception is raised when a system function returns a system-related error, like including I/O failures such as file not found or disk full. Okay, so if it can't find the file or something's wrong, it's going to throw up an OS error. Then we're going to go into this exception. Otherwise, value error, like it couldn't convert something, it couldn't convert our string into an integer, it will go into this one. And then otherwise, except print unexpected error, there's some kind of error that you have no clue what happened, and it's just going to go ahead and give out some information to you here. Yeah, they're all a little, it's not too bad following these because they're all sectioned off. So today we're kind of just learning about exceptions. There is a lot to read here, but hopefully I'm explaining it thoroughly enough to follow along of what they're trying to do in these examples. If you need me to explain a little more or you want to go through it a little bit more, just let me know. That goes for everyone. So the next one, I think we all understand what's going on here. They're just trying to handle reading in from a file, trying to convert whatever they read in, and it's only the first line in the file. That's going to come in as a string, and that string is going to get stripped down so it has nothing else besides characters or numbers in it, no spaces, and then it's going to get converted to an integer, a number, and saved in I. If it can't do any of these functions, either open up the file, read the line, for some reason, maybe permission issues, or convert a string into an integer because it's got characters in it instead of numbers, it's going to go through one of these three errors and not crash the program. All right, the try except statement has an optional clause which, when present, must follow all except clauses. It is useful for code that must be executed if the try clause does not raise an exception. For example, for arg in sysarg1, try to open. So they got to supply something from the command line, I assume here, and we're going to grab the first well, not the first argument, the second argument from command line, because the very first argument is always going to be the program name. And then I'm going to go ahead and try opening that up as a readable file. If they cannot open it up as a readable file, because the file, let's say, does not exist, it'll tell you that it cannot open that file. Else, it means it can. That's all. So they're going to try opening. If they can't open, then it's going to print out here. Otherwise, else, we're going to go ahead and print out some lines from the file. All right. Well, we're pretty much halfway through this already, so that's great. I'm going to go ahead and take just a moment here to take a brief intermission. I'll only be gone for about a minute. I'll be right back. All right, I'm back. So as we're going through these exceptions here, of course, a lot of programming languages have ways to handle exceptions, and they're great to use once you come out with kind of an end product, and you want to keep that in mind during the whole entire programming phase of let's say, you know, an end product that's going to go to I don't know, some customer, someone you're writing a program for. But most of the time, I don't even bother creating or handling, I should say, exceptions in my programs, just because I'm writing something quick and easy. It's not going to go to anyone else. I just want it to, you know, process something, get it done really quick, because this does take a lot of time, a lot of thought in order to handle all cases. Of course, if you're working on a big project that, you know, you want to handle mistakes by a user, so your program doesn't just crash. It's really good to understand these concepts. But otherwise, you know, you can get around not using them, of course. That's just a brief mention there. Let's see what else we got. The except clause may specify a variable after exception name. The variable is bound to an exception instance with the argument stored in instance args. For convenience, the exception instance defines string so that the arguments can be printed directly without having to reference args. One may also instantiate an exception first before raising it and add any attributes to it as desired. So I feel like we've gotten to the very wordy part of Python. That's a lot to digest there, especially for people who are beginning. Let's see if we can make sense of this here. Try. Raise an exception, spam eggs, except. So our exception, if we have an exception as an instance, print type inst, print inst args, print inst, unpack, print. Okay. So what they're showing you is they raise an exception by using an exception function. They pass some arguments into that exception. So this is if you wanted to handle a special case, a special exception that you wanted to go ahead and raise yourself, meaning you created the exception because you found something wrong. AKA, this is manually how to create an exception. That way you don't have to use all their built-in exceptions, right? So this exception defines a class and passes everything in as arguments. And you can see what they did was they printed a few things here. So they printed the first one, the exception instance. So they called this exception inst. So they called the function exception. They are looking for that exception, and then they defined exception as inst, so they can reference it as inst or an instance. So here, if they print the type of instance, it's a class. It's called exception. If they print inst.args, that's going to print the arguments stored in this .args. What do they call that? Well, they didn't call it anything, but it will print out all the arguments of the exception class, and you can see that spam and eggs. Otherwise, it's going to go ahead and print out the instance. So this is, I don't believe this right here is probably an object. This right here is probably a string, but doesn't, oh, let's see. String allows arguments to be printed directly, but may be overwritten in exception subclasses. Okay. So kind of the same, but can be overwritten in subclasses. Same thing as this up here, I think. Well, no, this is printing out the entire class. This is printing out the type of class. That's all. All right, and then finally, to unpack our arguments, so what we passed in, right? We can say x, y, and then inst, so we're referencing this object, and we're referencing the arguments in the object, and that unpacks them into the individual variables we have defined before. And then we get spam is equal to x and eggs is equal to y. Awesome. So that's just how to use manual exceptions if you want to go ahead and define your own exception. They offer a class for that. All right. You know, we're getting pretty far here. I'm going to keep continuing on. So if an exception has arguments, they are printed at the last part detail of the message unhandled exceptions. Exception handlers don't just handle exceptions if they occur immediately in the try clause, but also after they occur inside the function that they are called, even indirectly in the try clause. For example, define this fails. So we have a function called this fails x. They're dividing by 0, which you can't do. That's an infinite number. Try this fails. They're going to try calling this function and accept 0 division error as an error. So this is the error type from the built-in exceptions that we're trying to handle. And they just print the error. That's all they do here. Easy enough. Moving on, raising exceptions. The raise statement allows the programmer to force a specified exception to occur, for example. So we kind of already saw this, right? We saw this up here. They raised this exception. And they called the exception class as a function and just read out some stuff from that exception that they generated. But so raise is an important statement because this actually allows you to create manual exceptions and force an exception to occur because you realize there's some terrible error that's occurred in your program and you don't want them to continue until it, until you can correct it, really. Oh, well, it's good to see a tax action. All right, so a sole argument raise indicates the exception to be raised. And you can create some shorthand here. So raise value error is shorthand for calling raise a function called value error. If you need to determine whether an exception was raised but don't intend to handle it, a simpler form of raise statement allows you to re-raise the exception. Try raise name error. Hi there. Accept name error. Print an exception flew by. Raise. So what happens? An exception flew by. Name error. Hi there. Okay. Sure. So I think what they're trying to show us is that what they did. Yeah. So what they did is they raised an error called name error. And on the exception of name error, since we got one, right, it's going to pass in hi there. They're going to go ahead and print an exception flew by. So they didn't do anything with hi there, the exception. Well, the argument that they passed into the exception. Instead, they just went ahead and printed this out, and then they raised it one more time, meaning get out of this try except, and that's when it goes back to the next scope of a try except block. But if you don't have one, it's just going to go ahead and exit out of the program completely. So we can go ahead and give this a shot real quick. Confirm that that's what happens. I'll start up my program here. Let's go ahead and just try this out. Run it, and we get the same problem here. So what if we don't do raise? What happens? Now, it handled the exception, right? And didn't actually tell us anything. Because in this case, we truly do end up handling the exception. We don't pass it on to anything else. But if we push this raise in, or we put this raise in here, that actually raises the exception up one more level, but we don't have another try-catch block, so there's nothing that will handle that exception. So I wonder, let's see if we can demonstrate this a little better. What happens if we do try? And let's just do another except here. And let's see if it'll catch name error. And print, I caught the exception. See what that does. See, it raised it to the next level. That's all it did. Hopefully that makes sense to everyone. If it couldn't be handled in this scope of things, it went ahead and threw it out of this scope and tried passing it to the next one. If there's another try except, it's going to go ahead and try giving it to that. If there's no, name error defined here, it's not even going to go through here. So let's just, I don't know. Let's see if, does that exist? Probably not. No, I can't do that. But anyways, then it's going to go ahead and pass it out of scope, try in the next try catch, and it kind of looks like that, right? And it's going to pass that name error in here. And then, of course, move on. But if we did another raise, now it's going to go ahead and pass it back, and we're going to get some information from the actual exception handler of the compiler. Well, not the compiler, the runtime. It's saying basically, hey, there's no try except. I was passed an error. It's called the name error, and it said hi there. It's just giving you some information. All right, moving on. So user-defined exceptions. That's pretty creative there, Snaith. I like that. That's funny. All right. Programs may name their own exceptions by creating a new exception class. Exceptions should typically be derived from exception classes, either directly or indirectly. Exception classes can be defined which do anything any other class can do, but are usually kept simple, often only referring to a number of attributes that allow information about the error to be extracted by handlers for the exception. When creating a module that can raise several distinct errors, a common practice is to create a base class for the exceptions created by that module, and the subclass that to create specific exception classes for different errors. What a mouthful. I don't know about anyone else, but I talk about just the mess of words. So let's try reading the code and figuring out what they're trying to define here. So we have a class, they're calling it an error, and it's of type maybe exception. That doesn't make much sense. Oh man. Class, input error. Let's see, base class for exceptions in this module. So this is a base class called error. And you can pass an exception into it. That makes sense. Pass just means nothing's defined. So there are no statements to run. It's just a placeholder, is what we've learned way back in the day. Oh, Brad, nice to see ya. Welcome to the stream. Glad to see you again. All right, and then let's keep going here. So this is the base class called error. You can pass an exception into it. It does nothing. Class, input error. You can pass an error into this one. So an exception raised for errors in the input attributes expression, message. So expression is an input expression in which the error occurred, and a message is an explanation of the error. So this defines a function called init of itself, expression, and message. And then you can call self expression, self message to save those expressions and messages. All right, so far, so good. So this is another class that they're creating. And then finally, and the last class here is the transition error raised when an operation attempts to, or a state transition that's not allowed. Attributes, it has a few more attributes here: previous, next, and message. State at the beginning of the transition, attempted new state, and explanation of why the specific transition was not allowed. And then they define a few more members, right? So self previous, self next, self message. So when they say self, I assume the self of the transition error class. All right. So they're just kind of showing you a breakdown of how a class that handles errors might be created, right? So you have different types of errors, right? Input error. So this would be basically a general error, right? You can't handle it in anything else. Then you have an input error. Well, for an input error, what information do you need? An expression and a message. For a transition error, what do you need? Well, you need where you're going, where you came from, and a message. So that's really all they're trying to show here. Most exceptions are defined with the names that end in error, similar to the naming of standard exceptions. So they're saying most are called, let's see, they end with error if they're of a built-in exception. Sure, Pre, go ahead. Ask away. I'll just get to it here in just a moment. I'm going to keep going here. Maybe I can do a little bit of a QA at the very end of things. Most exceptions are defined with the names that end in error, similar to the naming. Okay, we already read that, sorry. Many standard modules define their own exceptions and to class or to report errors that may occur in functions they define. More information on classes is presented in the classes chapter, which I don't think we've gotten to, but we will. So 8.6, defining cleanup actions. All right, I think we only have 2 more sections to go. I think I'm going to go ahead and try finishing these 2 sections up. That way we can start up on a clean chapter number 9 next time. All right, the try statement has another optional clause which is intended to define cleanup actions that must be executed under all circumstances. For example, let's see, try raise, they're raising a keyboard interrupt. Finally, print goodbye world. So, finally, meaning this has to be ran under all circumstances, I think. Yeah. So that's finally is a cleanup function. And it says again, it must be ran under all circumstances. So you can go ahead, let's say you had a destruct or kill a an open file or something. You don't want to leave a file open. Either way, it's probably a bad example because I'm sure the garbage collection would actually handle that. But let's just say there was some memory allocated, memory hadn't been deallocated yet. Well, this is a good way to go ahead and handle everything at one final time before the program completely crashes. So that's all it's telling you. There's a finally clause inside a try except. Hey there, Anupam. Nice to see you. Thanks for joining today. Also, if you guys are new and stopping by, please make sure to hit that like button and think about subscribing to the channel where there's plenty of Linux videos, tutorials, and programming tutorials for that too, both in Python and C, C++. All right. So this is really pretty easy. They're going to try to return true. Finally, they're going to return false. So let's see. Let's read this real quick. If finally clause is present, the finally clause will execute the last task before try statement completes. The finally clause also runs whether or not the try statement produces an exception. The following points discuss more complex cases. All right, so that's why it finally returns a false here, because regardless of whether or not you tried this function or called this function, it has to return the finally statement. All right. In here, if an exception occurs during execution in the try clause, the exception may be handled by the except clause. An exception is not handled in except clause. The exception is re-raised after finally clause has been executed. All right, so it's gonna, if you have a try except, it's gonna try handling it in the except first. Then it's gonna go through the finally, and after the finally, it's gonna go ahead and raise that exception to the next try. Except blocked. Hopefully that makes sense. Let's see. Do we already have this here? We kind of do. So basically, let's go ahead and run. Let's see if we do a finally here. Will that work? Finally. See it. Let's see how this ran through. So what happened was, we went through this try, we raised an error, it said hi there as an argument. We do have an exception for name error, so we printed out an exception flew by, and we see that, right? Exception flew by. Oh, I think I'm a little too far there. Okay. Let's see. Okay, an exception flew by first. Awesome. And then we raised that exception. But before the exception got raised, it had to go through finally here. So it says finally. And then after finally, it gets raised to the next set of try except blocks. And we get a I caught the exception because we have another name error exception. And then we finally raise it one more time, which kicks us out of the program and just displays whatever exceptions we had. All right. So Pre's question here, real quick. I'm going to just do a little side note here. He wants to, I want to share a directory using Apache server on Manjaro. All right, so you're unable to share. So you're just trying to share directories between two computers. And do you want to share those directories on Apache, or do you want to share it between the Manjaro and, let's say, like a Windows computer or something else? Because if you want to do the latter, meaning the second half there, you'll want to just install something like Samba Server, and then you can go ahead and freely exchange files and whatever you have between a Windows computer and your Manjaro Linux computer. Otherwise, if you want to share, if you want to reach a directory that's in your Apache server, you can do that as well. It's kind of convoluted though. You would just put that file. Okay, so you want to do it through Apache. So Apache is a web server, and you can access your web server anywhere on your local network, I assume. And if you can do that, then you simply just have to throw your whatever file you want to share and use your IP address in order to access your web server from somewhere else on the network. And you can literally specify the file that you want to go ahead and access, and it will download that file through the URL. So hopefully that makes sense to you. So you can access it, you just have to throw it into, let's say, like the www HTML directory for Apache, and then you can access that file by going to another computer, typing your URL in, and then followed by / and then the file name, and it should try pulling that file down and downloading it if it can find it. Otherwise, you probably have either security permissions wrong and or ports aren't forwarded properly if you can't access your web server anywhere else on the network. All right, moving on here. So we already did this example, a more complicated example. Let's see. So we kind of did this, but we'll read through it. They define a function called divide, and they pass x, y into it. They first try to divide x by y and return the result. If they can't do that, they're going to say, hey, there's been a division by 0. So if they actually get a 0 for, let's say, y, so someone passed in a 0, they're going to say, hey, look, someone tried passing in a 0 and tried dividing by it. We can't do this. That leads us to an infinite number. Otherwise, if they do put in a successful number, so let's say they just do something divided by 1. So 2 divided by 1, they pass in 2, they pass in 1. It will do the result and then go through the else clause and print the result. Otherwise, let's say they had an exception, and they didn't raise the exception before the program exits out, because you're not really handling the exception in here. It's going to go ahead and go through the finally block and just say executing finally clause. So let's make sure that's true. Oh, geez, 2 by 1. That's exactly what I was talking about, but well, sure, it doesn't show you the files or directories inside there, but that doesn't mean that they don't exist. As long as you have the right permissions, you can literally put in, like, let's say you had backup.zip. Go ahead, put a / instead of naming index.html. Go ahead and just try typing in that backup.zip and then it should just pull that file down. It doesn't have to show you. If you do want a directory tree, there is a way to enable that with Apache. I don't think it comes by default, but you'll have to try just deleting your index.html file and see, or maybe even renaming it, and see if you get a directory, like a tree, and see if you can go through it. So we already went through this exact example without me even knowing. So let's just make sure that everything happens. So they tried dividing by 0. It says division by 0. It goes through the finally clause. That all makes sense. Here they just put in 2 strings and make everything fail, so they can't divide. And that's not a division by 0 error, so they move on. And it falls out of the program and tells you that there's an unsupported type error, and the 2 types that you passed were strings. All right, so yeah, and it says here, where in real-world applications, finally is great at releasing external resources. All right, everyone, we are almost done here. So if you haven't already, please make sure to go ahead and smash that like button for me. All right, so we have a question here from Anupam. Where is the idea of exception used in actual programming, and when is your next tutorial scheduled on classes? So I don't know when I'm going to do classes, honestly. Let me look. What's next here? Oh, classes is next. You looked ahead. I think I might be doing one tomorrow. I'm not sure at what time yet, but I will put it. If you're following my channel, you'll hopefully get a notification. So make sure to follow the channel if you're not already. And I think I'll do it tomorrow, sometime around the same time, hopefully, but I'm not sure yet. Otherwise, it'll be next week. And to answer your first question, in actual programming, especially if you have a full-fledged program where a user is constantly interacting with it, that's the best place to use it, because it looks really ugly if the program just exits out and the user has no clue why it exited out. You know, imagine you using, I don't know, let's say Microsoft Word, and you messed up, you did something wrong, you put some weird character in there that doesn't exist in the fonts, and the processor didn't know how to handle it. Well, instead of crashing without any kind of information, you get a little dialog box that tells you an exception number, an error, whatever, and then you can kind of go ahead and Google that and figure out, hey, this is what I did wrong, in order to generate something that the program really didn't like. So the best example always is division by 0. A program can't handle division by 0 because that is an infinite number. And a computer can't store an infinite number, therefore it just crashes. So you don't want your program to crash. Instead, you just want to tell your user, hey, you gave me a 0. I don't want to, I can't process this. Please give me another number. So it's kind of in that instance where you would, another example is handling like exceptions from databases. Well, you might get an error from a database and don't know what to do because something failed. Well, do you want to exit out of the program, or do you want to just try handling the case and looking for a special character maybe that the user gave you, and removing that special character and then requerying the database in order to get information into the database? Hopefully that makes sense to you. But there's plenty of examples where you could use exceptions. And it makes for cleaner code too. I mean, again, you don't get this ugly message here. Like, who wants to read this? Instead, you can just simply print out something or give a dialogue and then gracefully exit the program. It's really for the end user more than anything. Again, I wouldn't use this if I was making a very simple program that didn't that wasn't going to go to an end user, someone else was going to use it, then I wouldn't even bother. But otherwise, you want to make sure to handle all your cases and make your program as user-friendly as possible. Well, I don't know if you guys would be interested in me doing like a question and answer type deal. This is starting to become something like that, but it looks like you have quite some good questions here. Tax Action is asking or saying, it's hard for me to make a decision on what programming language to start learning from a part-time self-tech point of view. Yeah, that is hard. It's hard to start anywhere with any kind of project or anything that you're learning that's new, especially that's complicated, whether that be math, engineering, science, programming, art, whatever, any subject. Got a lot of thoughts on that, but honestly, I would start somewhere in between, an intermediate language that shows you how to program using object-oriented programming. That way you know how to structure your code, because structure really helps when reading code. If you don't have structure and things are just all over the place, aka you're not using object-oriented programming, it makes for a mess. And in the real world, once you start working with a team, that's really the only way to go. If you're just planning on doing it as a hobby, Python's actually a great place to start, just because it's got object-oriented programming. You don't have to handle memory like you do in C and C++, which is just overwhelming for a beginner. It's a lot to understand, especially if you have no notion of how the internals of a computer work. So I would not start there. C and C++ is just, it's too much to start with. So much. You got to handle memory, and then you're learning object-oriented programming on top of that. And also what it really boils down to is what you like doing the most. Do you like manipulating data? Do you like, designing user interfaces? Do you like web development? Do you like, having a person interact with the web browser and be able to access your program from anywhere? Do you want it strictly on desktop? Do you, all that too plays into it. We'll definitely get into this at a different time, Tax Action. And then I'll be able to answer it more clearly when I can think about it some more. I haven't used Google Flutter. I've heard about it, have not used it, so I don't really have an opinion on that. Sorry. All right, predefined cleanup actions. Some objects define standard cleanup actions to be undertaken when the object is no longer needed, regardless of whether or not the operation using the object succeeded or failed. Look at the following example. For a line and open my file text print line end. The problem with this code is it leaves the file open, of course, right? We open the file, we never called close. That's always an issue. So this is not an issue for simple scripts, but can be a problem for larger applications with using the with statement that allows the objects like files to be used in a way that ensures that they are always cleaned up promptly and correctly. So it's just telling you you can use these two functions, but it might be better to go ahead and use a with instead of opening up without a with. We talked about this already once in a previous chapter where it kind of explained the differences between using with and just opening up a file and trying to edit it. With using with, it will automatically clean things up for you versus not using with, it won't automatically clean up things for you. Oh, web development. Okay. Web development, that's a completely different bear. Well, you really need to know front end, back end, and to get you started, I would just use Bootstrap with, of course, HTML and JavaScript. Just get started there, and then you can work your way to the back end and hook up a database to save information. And yeah, at that point, I'd use maybe Node to bring everything together. But yeah, web development, I like being able to see stuff, so I do really enjoy, like, if you just start with HTML and CSS, it's fairly easy to use, and then introduce some kind of a framework like Bootstrap, which will help you create. It will let you, or help you create kind of a user interface. It's already got predefined objects like buttons and carousels and navigation bars and all that fun stuff. Yeah, start there. And it's still an overwhelming amount to learn, but you just got to take it one day at a time. Find yourself some kind of a website you want to make, and then just try using HTML, CSS, and Bootstrap to create it. Lay it out, get that done, and then start adding functionality to it. Don't worry about functionality until you can get something on a web page. All right, everyone, I think I am finished for today. Oh, HTML5, I don't even know if HTML4 is really supported anymore. Here, let me get you a resource real quick. Start there. W3 Schools, I think, especially if you like reading, is a great place to start. And they actually have mention of everything that I said, even Bootstrap. They show you how to kind of use Bootstrap. So get into Bootstrap, use that framework with HTML and CSS to create your first basic website. All right. Well, no problem. Hope to see you in another one, and we can talk more about this, and maybe we'll do a question and answer type deal here soon if others want to do that, where you can ask me Linux and programming questions, and I'll try to answer them to the best of my ability. All right. Well, I hope you enjoyed this stream of going through the tutorial on the python.org website. We are just finishing up with chapter 8. We're going to be moving on to 9, which is classes, next time. That's quite an exciting subject. I'm sure there's going to be plenty of information to go through next time. So we probably won't make it all the way through, but we are getting introduced to object-oriented programming with classes. And, well, I hope everyone enjoyed this. Thanks for everyone who stopped by and watched the stream. I will catch you in the next one.